This is Pre-Algebra, section 10-6. We're studying dividing monomials. My name is Mr. Rupp, and in this video, I'll show you how to multiply, divide, and simplify rational numbers using exponent rules. You'll learn how to interpret positive whole number powers as repeated multiplication, simplify and evaluate expressions that include exponents, and finally, how to divide monomials. By the end of the video, you should be able to add, subtract, multiply, and divide monomials and polynomials, and solve multi-step problems using these techniques. I've got my coffee, I've got my water. Let's get started. Hi. This week we're talking about dividing monomials. Last week it was multiplying monomials, and this week we're dividing them. So we have some vocabulary terms that we should get out of the way. Alright, since we're studying the same thing, basically, monomials and polynomials, the new vocabulary term that we've got to look at today is rational expressions. Okay, an algebraic fraction whose numerator and denominator are polynomials. That's what a rational expression is. Okay. So, remembering back from last week, a polynomial is a monomial or a sum of monomials, and all the variables can only have positive whole number exponents, and they cannot be divided by a variable. We have monomials, which is kind of at the base of all this, and it's a number, a variable, or a product of one or more variables. Okay? Pause the video, make sure you write this down in your journals. Looking at our example here, we're talking about dividing monomials, and we look at 5 to the 7th power, and that's being divided by 5 to the 4th power. Okay, so let's just write this out as a big giant fraction. 5 to the 7th means that 5 is multiplied together 7 times, right? 1, 2, 3, 4, 5, 6, 7. There they are in blue. And then down below in the denominator, 5 to the 4th means 5 is multiplied together 4 times. 1, 2, 3, 4. Okay? So that means that you can cancel however many 5s you have on the bottom and the top. Okay? So if you have 4 on the bottom, you can cancel 4 on the top. An even number in both places. So we cancel out all 4 5s from the bottom and all 4 5s from the top. And what are we left with? We're left with 5 multiplied together 3 times, or 5 to the 3rd. Alright? Well, rather than do that each and every time we have a problem, how about we look at this? Down below we have the quotient of powers. So if we took 5 to the 7th and divided it by 5 to the 4th, what we're really doing is we're going 5 to the 7 minus 4. Top minus bottom. Not so difficult, right? Which leaves us 5 to the 3rd. Okay, so there is the quotient of powers right here, the key concept. Yay, key concept! Right. Okay, and only they use 3 here. They have 3 to the 7th right here, and divided by 3 to the 3rd, which is 3 to the 7 minus 3, or 3 to the 4th. Okay? Right. Well, that brings us to our first problem here, where it says, example 1. Example 1 is on page 550. Okay? So it says simplify these and express it using exponents. Well, I'm not going to do the whole write out 4 8 times on the top and 4 2 times on the bottom. We've learned our quotient of powers. We're going to use it. So that means that 4, which is on top, divided by 4 to the 2nd power, which is on the bottom, gives us 4 to the top minus bottom, which is 4 to the 6th. This is all about integer math, okay? Integer math. Positives, negatives, all that jazz. I hope you remember. Because what I want you to do now is pause the video, okay? And try this one yourself. Alright, we're back. Hopefully you paused the video and gave it a shot. Okay. So how do we do this? Well, we have n to the 9th over n to the 4th. And in case you haven't noticed, I always find rewriting the problem to be the first step that I do. It kind of gets my brain kicked into gear and gives me a point to start. Alright, well that means the base is n. That's our common base. So the base is n, and it's top, which is 9, minus bottom, which is 4. So we have n to the 5th. If you got n to the 5th on your own, congratulations. If you didn't, well then we have some work to do. Alright, moving on. Now we got negative exponents. Negative numbers. Everyone's freaking out. Calm down. Negative integer math is not that difficult, okay? Here we have, well, let's look at the instructions first. It says simplify. Simplify means to take this problem right here and reduce it. Simplify it. If you had 2 over 4, you would reduce that. You would simplify that to 1/2. Same thing here. And then it says express using positive exponents. Now, I know that for some reason, almost everybody in this class hates reading the second sentence. I don't know why, but more often than not, the first half of the problem will be done, but the second half just gets ignored. Okay? Express using positive exponents. Now, in this case, there probably isn't any other way to do it, but if there is, you have to pay attention to the second part of the instructions. Alright, so using 6 to the 9th over 6 to the negative 3, using our quotient of powers, that becomes 6, because 6 is the common base. 6 to the 9 minus negative 3. Okay? Which becomes 6. Well, what happens when you take away a negative? It becomes a positive. 9 plus 3, just like that. And we all know what 9 plus 3 is, right? If you don't, back to second grade with you. Alright. 6 to the 12th. Our giant famous answer. Okay, so I can get my pen color back here. Thank you. Alright. So I want you to pause the video, and I want you to try this one yourself. Okay? Alright. We're back! Yay! And we all tried this all by ourselves, right? Right. So here we have w to the negative 1 power over w to the negative 4. Okay? Using our quotient of powers rule, it's the same thing. Even though there's negative signs here, nothing has changed. It's the top, negative 1, minus the bottom, negative 4. Alright, well that looks fairly ugly. Well, again, from before, what's minus a negative? A plus. So we have minus 1 plus 4. Well, that doesn't look so bad now, right? Well, what's negative 1 plus 4? Hopefully we all end up with 3. So this is w to the 3rd power. Yay, and the crowd goes wild. Okay, moving on again. Oh, here we have a very good problem. Okay, look at this. Well, we have a lot of things going on here. Remember back when we started this monomial business, and from even further back, you know, when we were sitting around the campfire as cavemen, and we're discussing negative exponents. You know, and Oog says you can subtract anything with negative exponents regardless of the base, and Og says no, you have to have a common base in order to work with exponents. And we all know that Og was right. We have to have common bases. So we have 2 as a base, 4 as a base, and 5 as a base. So you can only work with common bases. So what this problem turns out to be is this. 2 squared over 2 to the 5th, and that's all in parentheses, times 4 to the 5th over 4 to the 4th, and that's in parentheses, times 5 squared over 5 squared. Okay? Well, we just take this down one step at a time. Let's work with the first set. 2 to the second power over 2 to the fifth. Remember the quotient of powers. Nothing has changed here at all. We'll put it in parentheses to separate it out. That becomes 2 to the 2 minus 5, top minus bottom, times, now we work with the 4's, okay? 4 to the top, 5 minus the bottom, 4. Okay, and then we work with the last base, 5, top minus the bottom. Okay, well now let's work these out. 2 to the 2 minus 5 becomes 2 to the what? Negative 3. Very good. 4 to the 5 minus 4 becomes 4 to the 1. And here's an interesting one. 5 to the 2 minus 2. What's that become? Well, 2 minus 2 is 0, right? Is that our answer? Because I can tell you right now it's not. How about this? We can't combine 2 to the negative 3 and 4 to the first, right? Because they're different bases. So in this case, we have to break this out with positive exponents. So this is a negative exponent, 2 to the negative 3. Negative 3 means that it goes into the denominator with a positive exponent, 2 to the 3. 4 to the first power is just 4. What's this 5 to the 0 power? What number is that? 1. Anything raised to the 0 power is 1. 100 million billion Googleplex raised to 0 power is 1. Period. That's it. So what we have here then is 4 times 1 is 4 over, well, what's 2 raised to the third power? That's 2 times 2 times 2. 3. Hopefully we are all got our thinking caps on and it comes out to 8. So this reduces now to 1/2. Okay, 1/2, or from our multiple choice, C. All right, not so hard, right? I mean, it looked awful and it worked out just fine. That's the way math goes. Okay, if you want to pause the video and try this by yourself, be my guest. If not, stay tuned and we will work it out together. Okay, story problem time, word problem time. Everyone's worst nightmare, right? Everyone hates word problems because they're tough, they're hard to figure out. And dang, each one is different. It's never the same. Okay, I'm not going to read all this. What I'm going to get to is this. Here is the key sentence. Right here. And it says, about how many times as long is Hawaii's shoreline than New Hampshire's shoreline? Okay? And you guys are all starting to unravel your brains in your heads. Stop it. This is English. Okay? If I told you that something was 2 times as long, if x was 2 times as long as y, then if I said x was a foot, you'd know, or if y was a foot, you'd know immediately how long x was. Okay, it's twice as long. What's twice times 1 foot? 2 feet. Okay, so if I said that x is 2 times as long as y, how would you write that as an equation? Well, just translate it. X, which is x, is means what? Equals 2 times. Well, it's kind of hard to get any more plainer than 2 times, right? 2 times as long as y. 2 times y. Okay? Or, you know, in grown-up math, 2y. So x equals 2y. It's the same thing here, okay? Only they've worded it differently. About how many times as long? How many times? Well, here we said it was 2 times. Right now, though, it says how many. That sounds like an unknown, okay? So over here, we're going to let b equal how many times? All right? As long is Hawaii's shoreline, okay? So b, how many times b as long is, okay, Hawaii than New Hampshire. So it's b times New Hampshire is Hawaii. Okay? So I'll rewrite it down over here using state abbreviations. So Hawaii is equal to b times New Hampshire. How many times as long? Well, now we have figures. We just drop them in, right? Or we could solve for b because that's what we're looking for. So why don't we do that first? So let's solve for b. We divide this side by New Hampshire, and we divide this side by New Hampshire, right? So then that becomes b, which is how many times, is equal to Hawaii divided by New Hampshire. Well, we have Hawaii and New Hampshire. Hawaii's total shoreline is 2 to the 10th. New Hampshire's total shoreline is 2 to the 7th. Boy, doesn't that look like a problem that we just got through doing. Same type of problem, right? Quotient of powers time 2, since they both have the same base. Top minus bottom. 2 to the 3rd. How many times as long is Hawaii's shoreline than New Hampshire's shoreline? 2 to the 3 times as long. And that is that. So, thank you for watching this video to the end. This was a very straightforward section, and hopefully this is making sense to you. If it doesn't, go back and watch the sections, the examples where you're confused. If you have problems that you can't resolve here, then email me and I will help you through them. Thank you, and I'll see you next time. Bye.